Of course, we're asked to find f prime. It needs work. What do I have to do first? Yes, x to whatever, you want to put 0. Is 0 okay? 1 okay? 0. E to t squared dt plus the integral from 0 to x squared e to t squared dt. And then I have one more step before I differentiate. So please do not be afraid of this type of problem at all. So this is negative, the integral from 0 to x e to t squared dt plus the integral from 0 to x squared e to t squared dt. Now this is ready to find f prime of x. And it has to be a function in x. So, minus that is nice. And times x prime, but x prime is good. Plus indeed times, that's it. I have only one more type of problem left over, and which is from section 5.2. Okay, so 3 properties of definite integrals, in addition to what we talked about, the integral from a to a and the reverse, the integral from a to b equals negative the integral from b to a. 3 more. Here's one. They're all common sense, pretty much. I think it's going to be very easy to understand. So if I have a function that is positive, like this one, so between a and b, on the interval a comma b, so a comma b, the function is this. Will you agree that the area under the graph from a to b from f of x dx must be positive? It's clear, right? Common sense. Second one, still common sense. If I have this situation, on the interval a comma b, I have a function f of x, and I have a function g of x. And by construction, I hope you agree that for the interval a comma b, I don't care outside, f of x is less than or equal to g of x. For any value, for any x value between a and b, according to my graph, f of x is less than or equal to g of x. Would you agree with that? Then you must agree with this. Please watch for a second. The area under the graph of f of x between a and b must be smaller than or equal to what? Under g of x, right? So if this function is here under g of x and g is above, the area under g must be greater than the area under f. Agreed? Common sense. One last one. Promise, and there is nothing else new this semester. This is the last topic. The third property, and again, I will say common sense. So here's a function between a and b This is f of x. And I have two numbers. I have a number here called m, lowercase m. And let's say I have a number up here, which is our uppercase m. Would you agree that f of x for the interval a comma b, I don't care what happens outside of the interval, but for the interval a comma b, f of x is between lowercase m and the uppercase m on the interval a comma b? Agreed? Therefore, I would like you to tell me what to write concerning this, and concerning this.
Lowercase m times b minus a.
Exactly. But first, I have to write this, which means the area under lowercase m must be smaller than the area under the graph of f, which is definitely smaller than the area under uppercase m. Would you agree that this is common sense? If a function is between little m and uppercase m, the area must follow the same relation. Okay. And yes, Tom went ahead and said m times b minus a, because that's what the area is. B minus a times the height, because this is a rectangle. B minus a times the height. And this is b minus a times the height. So, less than or equal to the integral from a to b from f of x dx, less than or equal to uppercase m b minus a. So these are the last three properties. And we want to apply them in a couple of problems. Okay. Let's start with a what I think it's going to be an easy one. 59. Page 384. Use properties of integrals to estimate. Estimate the integral from 1 to 4 from the square root of x dx. Can I calculate this? Easily. Because I know that the square root of x has an antiderivative, which is x to 3/2 over 3/2. Now it's so embedded in our memory, right? So that's not a big deal. But what we are asked to find is, find an upper limit if you want an upper number like uppercase m and the lower number lowercase m. That's what they're asking us to do. They're not saying calculate it. Okay. They're saying estimate it. Okay, so where do I start? When I look at the integral from 1 to 4 from the square root of x dx, where is my starting point? It's x. This is what I have. This is my starting point. This is what the integral is telling me first, that whatever you do, the interval a comma b is 1 comma 4. Agreed? Okay. Now, I would like in the middle to have what? Not x, but the function, the f of x. So I have to build this. Why? Because of this property. For now, I have that x is between 1 and 4. But if I build the function in here, then I can determine the integrals. Okay. So, what I would like to do to all three sides is an operation that sometimes is legitimate and sometimes is not. What operation would I love to apply to all three sides? Square root. But I can apply it only if I know for sure that everything is positive. Otherwise, I can't. But if I'm told that x is between 1 and 4, Very clear, everything is positive here. 1 is positive, the middle is positive, 4 is positive. So only now I'm allowed to do that. I'm not always allowed to do that in a square root, in an interval, in an inequality, sorry. I'm allowed to do it in an equation, but not in an inequality. Okay? So in this case, because all three sides are positive, I will say apply square root. Okay. When I apply the square root on the left-hand side, what do I get? When I apply the square root in the middle. And when I apply the square root on the right-hand side, 2. So I did find the lowercase m. I do have the function of interest in the middle, and I do have a uppercase m. All I have to do is now say the integral from 1 to 4 dx, the integral from 1 to 4 dx, and the integral from 1 to 4 dx. By property 3. So what do I have from coming from the first one? Exactly. 4 minus 1, which is 3. Awesome. Less than or equal to. I'm not allowed or supposed to do anything with the middle. I'm only supposed to estimate a lower limit and an upper limit. And what about the right-hand side?
2
by 3. Very good. Awesome. Now, can I determine this and see what it is? Yes, but it's definitely a number between 3 and 6. And this is another application of, or a solution, I should say, to, when I'm given a definite integral whose function I cannot find the antiderivative. I can't. There are many, many functions for which we cannot determine by hand an antiderivative. I will be able to estimate it. As long as I find a lower limit and an upper limit, I will say, oh, I can find the antiderivative. I can find the exact area, but I'll tell you for sure it's between 3 and 6. Any questions? Okay, so let's look at another. 57, I see it in red. Let's take a look. 2 less than or equal to the integral from -1 to 1, the square of 1 plus x squared, dx, of course, less than or equal to 2, the square root of 2. It says use the properties of definite integrals, they should say, not integrals, but definite integrals to verify the inequality without evaluating. We cannot. We cannot evaluate this today. But if we use a trig substitution, we can. But today we cannot do it. So, where is my starting point? Even with the trig substitution, I'm thinking, I have to look at it. We may not be able to. Correct. But where is my starting point? And it must be that, for sure. Very good. That must be my starting. This is what I have. This is guaranteed. I'm told the integral from -1 to 1. So x must be a number between -1 and 1. Okay. What am I trying again to build in here? The function, slowly, piece by piece. Okay. So I have x, but the function doesn't have x. What do I want? I wish I could square all three sides. I can't. That's not how it works. In an inequality, I can do it in an equation, but not in an equality. So now let's think. X is a number between -1 and 1. So imagine numbers between -1 and 1. And let's think, where will those numbers squared, if I square all those numbers between -1 and 1, what is the minimum number I get?
0.
Perfect. What is the maximum number I get?
1.
Correct. So be very careful. If and I did not square both sides, all three sides. If x is a number between -1 and 1, it is guaranteed that x squared will be a number between,
0 and 1.
that's it. I'm closer. So the function has 1 plus x squared. I have knowledge about x squared now. What can I do, and I'm allowed this time, to do to all three sides?
Add 1.
Correct. So I'm adding 1 to all three sides. 1 less than or equal 1 plus x squared less than or equal to 2. Because all these numbers are guaranteed to be positive. I am allowed. Otherwise, I won't. I am allowed to do what?
Take the square root.
Yes, because the function has this, not because I want to, but because the function has the square root. So I'll say apply square root. So 1 less than or equal to the square root of 1 plus x squared less than or equal to the square root of 2. I found the lowercase m, I found the uppercase m. From this point on, what do I need to do? Definitely the area under 1 must be smaller than the area under this and must be smaller than the area under this. So I put that in. dx, 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 not everywhere, but definitely between -1 and 1. And we're talking about area, so it must be a definite integral. So now, final step, I evaluate the left, I evaluate the right, and I'm done. Yep. So, the left-hand side, the distance is 2 times 1. 2. Less than or equal to -1 to 1, the square root of 1 plus x squared dx, less than or equal to
2 times.
and this is what we were asked to oh, where's my problem? Oh, right here. This is exactly what we're asked to do. I think we should look at another and then start reviewing. What do you think?
Sounds good.
Yes? Okay, let's say 56. In 56, they say the integral from 0 to 1, the square root of 1 plus x squared dx is less than or equal to the integral from 0 to 1 from the square root of 1 plus x dx. So which property would you have in mind? This one? No. This one? No. The second property, exactly. When I have two functions, I have to show that this one is below this one, and then the integral will be below the other, the number, right? Okay, so where's my starting point? And it has to be with
The function.
x. And with the functions, exactly. Good. If x is between 0 and 1, I'm okay with squaring all three sides, because these are positive numbers and I can square and get, so forget about the second function for now. We're trying to look at this function. Okay? So I can say 0 less than or equal to x squared less than or equal to 1. That's clear. If a number is between 0 and 1, that number squared will still be between 0 and 1. Agreed with that? Okay, perfect. In order to build this function now, what do I need?
Add 1.
Very good. 1 less than or equal to 1 plus x squared less than or equal to 2. In order to build this function, I have one more step, knowing that everything is positive from 1 to 2. What do I want? Good, so 1 less than or equal to the square root of 1 plus x squared, the square root of 2. Okay, so I have an idea of where this function finds itself on the interval 0, 1, somewhere between 1 and this. Now I want to see what this happen. What is this? So I do have that x is between 0 and 1. I am allowed to add 1 to all 3 sides. And all positive. So I'll say 1 less than or equal to the square root of 1 plus x, and less than or equal to the square root of 2. So wonderful. But it doesn't tell me the relationship between those two. But I have to think for a moment. Which of these two, because I didn't get anything significant between these two yet. So then I have to go back and think in those terms. If x is between 0 and 1, which of the numbers, x or x squared, is smaller?
X squared.
Correct, is smaller, because when you square 1/2, you get 1/4. Excellent. So I will say that when x is between 0 and 1, definitely x squared is less than or equal to x. I need to add 1 to both sides, which I'm allowed to. So I have 1 plus x squared less than or equal to x plus 1. And I'm allowed to take the square root because they're all positive. So bottom line, I did not need to build the functions. So this was not necessary. I just wanted to see where this is going and where this is going, but this wasn't useful. So I'm going to go back and say, not useful. Nice, but in this case, not really useful. This is. And now I can integrate from 0 to 1 dx, from 0 to 1 dx. And I know that this is what they were asking us to do. One question that I would like to, because I think I selected a problem like that, so I want to show you. Express the limit as a definite integral. So we have limit as n approaches infinity from the sum from I equals 1 through n from xi multiplied by natural log of 1 plus xi squared times dx. And the interval is 2, 6. I think I selected a problem like that. And I want you to have an example. Okay. We're not asked to evaluate. We can. We're only asked to say, okay, this limit of the Riemann sum is the same with the integral blah, blah, blah dx. That's all they want us to do. And we will be able to evaluate this one if we want to. Limits of integration first. Very good. Function. Of course, this one must be this. There is no question. This is just a function. That's all. X, natural log of 1 plus x squared. This is it. Right? Because this is f of x, so the limit of the sum from I equals 1 to n from f of xi delta x. Delta x is dx, and this is our function. Can we evaluate it? Yes, we can. Because we can use the substitution. Let's do it. The problem in this case is not asking us to, but we can. We'll say let u be
1 plus x squared.
Indeed. And du will be?
2x dx.
Awesome. So 2 in front and 1/2. Remember, we can always multiply and divide by 2. That's never going to change anything. So now the new integral, and please do not copy the limits of integration. When x is 2, how much is u?
5.
Very good. When x is 6, how much is u?
37.
Very good. Awesome. And now please change natural log
U.
du. I spoke too soon. Stop. Calc 2. Integration by parts. Chapter 7. Sorry, spoke too soon. That's why we were not asked to determine this. We don't know how to find the function whose derivative is natural log. We don't know. We have to use integration by parts. That's why we were not asked. We were just told, show the definite integral, don't evaluate it. It makes sense. So I said chapter 7. I'm done with everything that I needed to show. We did not skip anything. We did not forget anything. So now I would like to go back to whatever you want me to. Yes.
For
Yes.
right before the properties.
Yes.
Definite integral.
Yes. In the notes
the
today.
last-
In the notes
yes.
today. Okay.
That the end of that problem, I wasn't sure how you got uppercase F prime.
This one. Or this one.
It was at the end of the problem. I can't remember what. Yeah, it was that one.
Okay. So let's take a look again. Okay. So first of all, I see that this is not a constant. So I have to break this interval. Sort of an interval, right? There are two functions, right? So I'll say from x to 0, and I have to start where I ended here, from 0 to x squared. Then I had to reverse these. The bottom one, the bottom limit, the lower limit must be a constant. It cannot be a function, or x. Even x is a function though, but you know what I mean. So we reversed from 0 to x with negative in front, from e to t squared dt plus this that we copied. So far so good? Okay, now I'm ready to differentiate. When I differentiate, this integral symbol and dt go away, and I replace t by x. So I have negative e to e raised to x squared plus. When I differentiate this integral, instead of t I put x squared, but x squared squared is x to the 4th, times the inner function prime, which is 2x. Why didn't I do it here? Because x prime was 1. Better? Good. Other questions? We can work on one. There is one here at the very end. If you'd like to start with that, we can do that. Is that what you would like to do?
Sure.
Okay, so let's start with that.
Oh,
It's what I handed out, yes. The very last one.
oh,
Very last, on the back. So we have f of x, the integral from 2x squared to tangent x from t squared over 1 plus t dt. This is a function given in the form of an integral. We cannot be asked to find the integral. We can only be asked to find what? The derivative. Correct. So, is this function given to us in the form of an integral, is it ready for differentiation? No. So how would you write this?
plug in the other one.
No, we are differentiating, but it's not ready for differentiation. Yes, Nick?
The integral something.
Okay, so you already want to change it, but then you have to put minus in front.
Yeah.
Okay, very good. We can do it in one step. From 0 to,
2x.
very good. From t squared over 1 plus t dt, and then plus the integral from, still 0. Very good, awesome. T squared over 1 plus t dt. Now this is ready to find f prime. So remember, when the limits of integration are functions, you cannot be asked to find the integral. But you can be asked to find the derivative. Okay, so then what next? Minus in front. Yes. Minus in front.
Minus 4x
Very good.
over 1 plus 2x squared.
Very good. Times 4x. That's okay. That's why we're reviewing this and doing it again. Plus.
Tan x squared
Yes, very good. Over.
over 1 plus tan x times sec squared x.
That's it. We can only be asked to find the derivative. Since we worked on several problems like number 7, let's work on number 7 now, if that's okay. We'll do the rest, whatever we cannot do today.
There's another one.
Yes. Yes, yes, please.
It's number 8 on page 369.
Let's take a look. Is that problem clear? Is the f prime here clear?
Yeah.
Okay, 369. 377, 369. And that's problem 8. Yes. So you will graph the function. You will determine the leftmost point and the rightmost point for n equals 3 and n equals 4. And then you will say this is the lowest and this is the upper. This is the smaller and this is the higher. Illustrate with diagrams like figure 14. So I will graph the function between -1 and 1. So this is x squared plus 1. And it says with n equals 3 and n equals 4. So when n is 3, delta x will be 2 divided by 3, kind of ugly. When n is 4, delta x will be 2 divided by 4, which is 1/2. So if I want to find the area with L3, leftmost point 3, so this is 2/3. I will say approximately with the left f of -1 plus f of -1/3 plus f of 1/3, everything multiplied by 2/3. Base times height, base times height, base times height. And then I will determine the rightmost point, which will be 2/3 times f of negative 1/3 plus 2/3 times f of 1/3 plus 2/3 times f of 1. This will be the rightmost point. And then I'll see which one is smaller. And I will see I will say this is the upper and this is the lower. And I will repeat for 4. But this time I will have 1/2, 1/2, 1/2, 1/2. So I will have -1, f of -1 times 1/2 plus f of -1/2 times 1/2 plus f of 0 times 1/2 plus 1/2 times f of 1/2. Because I will have this interval, -1, -1/2, 0, 1/2, and 1. So I'll have f of -1 times 1/2 plus f of -1/2 times 1/2 plus f of 0 times 1/2 plus f of 1/2 times 1/2. If I want the rightmost point, I will have 1/2 times f of -1/2 plus 1/2 times f of 0 plus 1/2 times f of 1/2 plus 1/2 times f of 1. However, because of the symmetry of the function,
Left and right are the same.
left and right are the same. Because it doesn't matter. So I can look at it this way, or I can look at it this way, right? It's still the same thing, because it's symmetric.
Is the midpoint still the same?
You can determine the midpoint. You can determine times 2, actually. Yeah. Very good question. Is this good enough?
Oh, it's better.
Okay. Anything else? Can we stop after we do one more problem? Yes? Okay. So let's do problem 8. Unless you have other questions for me. So from 0 to 1 e to the x cosine x, they say it's this. We cannot determine with what we know so far the integral from or the antiderivative of e to the x cosine x. Oh, what did I forget? I can never forget the x. The integral does not exist without dx or dt or dv, whatever. Okay, where is my starting point?
0.
Yes, so x is between 0 and 1, correct. Now this is a little bit tricky. Forget about e to the x for a moment. Let's graph cosine x between 0 and pi over 2. Is pi over 2 exceeding 1? Yes. 3.14 divided by 2 is exceeding 1. Okay, so 1 is somewhere here. Okay, so let's graph cosine between 0 and pi over 2. How much is cosine at 0? Perfect. How much is cosine at pi over 2? Awesome. That's all I care about. And basically, I'm only interested in what happens between 0 and 1. So what will I say? What will you say if I say this? Cosine 0, cosine x, cosine 1. Careful, look at the graph and indicate the sequence of symbols. And where do they start? And which one is the biggest?
The biggest.
Correct. So be very careful. This happens because the function is decreasing. Very good. This is a bigger number than this one. Cosine 1 I don't care for. It's cosine 1. Cosine x, and then you already told me that this is 1. Okay. I peek here for a moment and I see a left-hand side and a right-hand side. I don't care for this part then. It's not a mistake to keep it there, but I don't care for it. It's a waste of time. Okay, so far I built cosine x, but I have to build e to the x cosine x. What should I do to both sides, knowing that e to the x is definitely and always on 0 to 1 and everywhere else? What type of number? Positive. So I'm going to multiply by e to the x because it's always positive. Furthermore, on 0, 1. So this e to the x cosine x less than or equal to e to the x. And I'm done, basically. I'm using the second property. I found a function on the left and a function on the right. What do I need to do now to finalize this? Exactly. From 0 to 1 dx, from 0 to 1 dx. I can't do anything to the left-hand side, 0 to 1 e to the x cosine x dx, but I can evaluate the right-hand side because I know the antiderivative of e to the x. It's the nicest function ever. E to the x from 0 to 1. When I plug in 1, I get, when I plug in 0, I get, and that's all we wanted.